Okay, assalamu alaikum. This video regards the study guide sheet for math. We will explain and go over each question in this question bank paper. And we may begin with our first question, which is at time t, the population of a particle moving on a curve is given by x of t equals 3t squared plus 10, and y of t equals t squared minus t. At t equals 2, what is the speed of the particle? So, speed of particle, we know that the general formula of speed equals to, in calculus at least, and this is, I like this question, it merges calc with physics, okay? So speed is equal to dx over dt squared plus dy over dt also squared. Now, what is dx over dt? So if we go here, x of t, if we get the derivative of this function, we will get dx of dt. So we just need to get the derivative of 3t squared plus 10. And we may apply the power rule here. So the 2 will go down, it will become 2 times 3 t, and then we will subtract 1 from the power. So 2 minus 1 is 1. Hence, we don't need to write it. So 2 times 3 is 6, and then t, we just write it as it is. So dx over dt equals 60, okay? So this is dx over dt. Now, let's get dy over dt. Hence, we need to get the derivative of this function, aka t squared minus t. So, again, we will apply the chain rule, not the chain rule, the power rule. So 2 will go down, it becomes 2t, minus 1 from the power, it becomes power 1, so we don't have to write it. Minus, if we have variable, it becomes 1. So dy over dt equals 2t minus 1. Now, we may substitute it in our equation or the formula. So it becomes 6t squared plus 2t minus 1 again square. But we cannot forget about the fact that they gave us the value of t, which is 2. So we will put 2 here instead of the t, and here again instead of the t. So 6 times 2 will be 12. Hence, we write 12 squared plus 2 times 2 is equal to 4, and 4 minus 1 is 3. So our equation becomes 12 squared plus 3 squared, which is equal to 144 plus 9. Finally, the final answer, aka therefore speed is equal to 153. Obviously under the square root. Moving on to question number 2. Okay, so let's solve each question independently. So part A, do the rectangles represent a left sum or right sum? So how do we identify whether the rectangles are representing a left or right sum? Basically, if we have two triangles here, rectangles, that's the first one, and this is the second one. Okay, so if we see a curve touching the rectangle from the left side first, hence that means that this is what we call left sum, and usually they are underestimate, but in this case they are overestimate. But that's what you get. You get the idea. So this is the left side. This is the left side again. It's touching the left side of the rectangle. But if it touches the right side of the rectangle, the right corner, we call this a right sum. So this is right sum, and this is left sum. So in this case, is this a right sum or a left sum? Are the triangles or rectangles representing right or left sum? We see that the curve here is touching the left side first, and then again the left side, and then again the left side. But it is actually the right side, my bad. The right side, the right side, the right side, right side, right side, right side, right side. So this represents right sum. Apologies for the mistake. Moving on to question B. Do the rectangles lead to an upper or lower estimate? So we have the curve. If we have area above the curve, like this, we see there's still room over the curve, part of the rectangles over the curve. We call this overestimate. Overestimate. And vice versa, of course. If there's area under the curve, we call it underestimate or lower estimate. What is the value of n? N is basically the number of rectangles that we have. So we have here 1, 2, 3, 4, 5, 6, 7, and 8. Hence, n equals 8. And let's just change the color. Finally, what is delta t or delta x? Sometimes they call it delta x too. Be careful. So delta x, we have a general rule for delta x or delta t, which is equal to b minus a over n. Now n we already got, which was number of triangles or rectangles. So here it equals 8. But what is b and what is a? And b is basically our interval. So our interval goes from 0 to 24. So 24 is b and 0 is a. So we may sub them in. A, as we said, is going to be 0 minus b, we said, will be 24. So 24 minus 0 will be 24. Divided by 8 will equal 3. So delta t equals, or delta x equals 3. Now let's solve the questions again, but this time with the second graph, and this time we'll do them or we'll do them quicker. So here we say the graph is touching the right and right sum, but this touches yeah, I was right actually. This is the left sum. Okay, I thought something was wrong. This is left sum, and this one we see the right sum. Okay, so you may make a mistake here, but if you revise it and look careful at it, then you will get it correctly. So this is right sum. And question B is, do rectangles lead an upper or lower? We still see area above the curve. See? So this is overestimate. Then C, the value of n, number of rectangles we have, 1, 2, 3, 4, 5, and 6. So n equals 6. And finally, delta t is equal to 12 minus 0 divided by n, which is 6. So 12 minus 0 divided by 6, which will equal 2. So this is delta t slash x. Moving on to question number 3. Use figure to find this is our figure. Okay, I was confused for a second. To find the integral 3 to 6. Basically, what does the integral mean? Integral means if we have a definite integral, so let's say from 4 to 5, they're asking us find the area under the curve from the interval 4 to 5. In this case, our interval becomes 3 to 6. So let's go here. They want us to find the area under the interval 3 to 6. So this we see here. Everything here they want us to find. If you can see it, if it makes it clearer. So we can just count it simply. We don't have to use any long formulas. So this is 1, 2, 3, 4, 5, and a half. Why are we saying 1? Because the length and width is both 1. So 1 times 1 will be 1. And that's how we get the area of the rectangle. In case, let's say, for example, this was 2 and this was 1. So the area under each rectangle will be 2. So this becomes 2, 4, 6, 8, 10, and 1. It becomes 11. But no, it's 1 times 1. So 1, 2, 3, 4, 5, and a half. So 5 and a half is the correct answer. Moving on to question 4. Given that, okay. So they've given us the integral notation 1 to 5 of g of x dx equals 8. Find, this time they put 3 here. Same thing, same equation, but they just put 3 here. And we learned one of the properties of integral, that if we have a number, let's call it c, behind the function, then we can put it in the back. It becomes 3, and then we just write the entire the integral and the entirety of the equation is the same. So 1, 5, 3, g of x dx. So here times. So this we already got as, it's here, same thing, we already got it as 8. So we'll put 8 instead, which will get us 24. The average value of the, so they want us to find the average value over the given interval, which is 1 plus x. Now, what is the rule of the average value? The average value rule basically states b minus a, so 1 over b minus a, times here it should be a to b of g of x dx. Now let's sub in our numbers. 1, same thing, it will be, it's constant. B minus a, so this is a and this is b. So b will be 4 minus 0, so since it's minus 0, nothing will change. Times, now again, integral notation. So a, we said is 0, b is 4, and then g of x, they gave it to us as 1 plus x. So 1 plus x, then dx. Okay, now, let's get the integral first of 1 plus x. And if we have, so let's say the derivative of x will be 1. Hence, the integral of 1, we will go backward, it will be x. So the integral of x, the integral of 1 will become x, plus, to get the integral of a variable, we will increase the power by 1. So here, integral of x, we will increase the power by 1. So if it's here power 1, x power 1, we will increase it by 1, becomes x power 2, and then divide by the new number we have as the power, which is 2 in this case, okay? So x squared over 2, this whole thing will sub 0 to 4, and times 1 over 4 is the same. So let's sub in 4 first, it becomes so 1 over 4, same thing, times x, we'll put 4 plus x squared, it becomes 4 squared divided by 2, so 4 squared is 16, and 16 over 2 will be 8, and 4 plus 8 will be 12, and 12 times quarter is equal to 3. Please, okay. So this is our final answer. The average value of the function g of x over the given interval is 3. Given functions f such that f prime of f prime equals f, in one case let f of 0 equal 0, and in other let f of 0 equal 1. Okay, so they want us to draw the they want us to draw two, they've given us two initial conditions, and we will draw both of them. So our first initial condition will be f of 0 equals 0 and f of 0 equals 1. Now we have two rules in this case. We know that if f prime of x is above the x-axis, then we will use the f then language, then f of x as the integral, and this is the derivative. So then f of x will be increasing. Our second rule is if f prime of x is increasing then f of x as the integral will concave up. And of course, vice versa to both of these rules. So let's start solving each question. So we will start with our first initial condition as f of 0 equals 0. So we'll start from 0. And here we see that they've given us f of x as the derivative. So we see that the function, the derivative function, is under the x-axis. Hence, what will happen? The function will decrease. So it will decrease until 1, and then a critical point or a sharp corner, there will be an undefined point. It started increasing, and we know it's non-differentiable because there's a jump. It's discontinuous. Hence, it will go up like this. Again, we will mirror the exact graph, just that it should start from 1. Okay? Here it will be the opposite. So the f of x is increasing, hence, it's the above x-axis, so it will increase until suddenly it jumped. Now it's decreasing because the f of x is under the x-axis. And again, we repeat the same exact graph at 1. And finally here, there's an increase, but at one point, or at 1 exactly, we see it shifts from being under x-axis to above x-axis. Hence, the graph starting from 0 should be decreasing. Let's just make it more clear. It will be decreasing until 1, and then it will start increase. And this is for our first initial condition. Again, this will mirror our second graph. So we see that we apply both of the rules. One, it is increasing, hence it's increasing all the time, hence it should be concaving up all the time, which is true here. It's concaving up all the time. Same thing here. It's the same graph, so it should apply the same rule as the first graph or curve or parabola. And at the same time, when it was under the x-axis, the parabola was decreasing, and when it became over the x-axis, it surpassed the x-axis and became positive, the positive tangent line, then it started increasing. Okay, so moving on to question number 7. So we have a very nice question from the lesson 6.4, stating and teaching us about the fundamental rule of calculus part 2, which is, if you have a derivative and then you have like an integral, then the derivative and integral will delete each other, and you'll be left with the x. You'll sub it in the place of t because it's to the respect of t. So it becomes sine. Instead of writing t, you just write x, and the rest of them are the same. Moving on here, so the integral of velocity, we know that here, distance, if you get the derivative of distance, it becomes velocity. And if we get the derivative of velocity, it becomes acceleration. But since we're moving or we're dealing with integrals, we're gonna move the other way, the other direction, which is if we get, so this is derivative, and if we get the integral of acceleration, we get velocity, and if we get the integral of velocity, we get distance. Hence, the answer for question number 8 is distance. Moving on to question number 9. Find the indefinite integral. So before you do anything, before you start solving 3e power x plus, no. You have to note, once you see indefinite integral, right away, first thing should come in your mind is plus c. Because this is what most students forget. I even tend to forget them most of the time. And you will lose marks on such a simple thing. So please do not forget to write plus c at the end of your answer. So we may begin solving the question. So the indefinite integral, we will apply the first rule of fundamental theorem of calculus. And actually, no, that doesn't apply. That only applies for definite integrals. So 3 will go. We will distribute the integral for each term here. It becomes the indefinite integral for 3 times e power x plus indefinite integral for cosine x plus indefinite integral for 5 over x. So 3 will go at the back, as we said. If we have a number, or aka c, behind a function, an integral, then it can go back. And the integral of e power x will be the same, because what is the derivative of e power x? The derivative of e power x will be e power x ln e. And ln e will obviously cancel each other, ln and e. Hence, you just get e power x. So if we move backwards, this is as derivative. So if we move backward as an integral, the integral of e power x will still equal e power x. So that's just a simple way of showing why integral of e power x equals e power x. So we'll get 3 e power x, it will be the same, plus integral of cosine, it will be sine x, plus finally here, 5 we can put it in the back, because 5 times 1 over x is the same as 5 over x. So it becomes 5, and then we write this integral of 1 over x. And we know integral of 1 over x is ln x. So it becomes, this becomes our final answer as 3 times e power x plus sine x plus 5 ln x plus c. Okay, see, I was gonna even forget about it now, even when I just warned you guys about it. Plus c. Do not forget plus c. Moving on to question number 10. Find the solution of the initial value problem. So initial value problems. They are very fun because you get to solve it step by step and everything makes sense. So we need to get the value of y, as in y of x. How do we do this? So in order to isolate y, we need to obviously multiply d over dx both sides of this equation, left and right side, or we can just transfer dx to the other side. It becomes dy. Actually, let's solve it in the left corner so that we have enough space to write comfortably. So dy equals x power 3 plus x power 4. So x power 3 plus x power 4 times, or let's just write dx times dx like this. Now, to get rid of d here from the y, we get the integral of both sides. So integral of this and integral of that. Integral and d will cancel. We get y equals, now the indefinite integral. Again, I said indefinite integral, hence we will be dealing with c. So the indefinite integral of x power 3, we will add 1 to the power. It becomes 3 plus 1 becomes 4, and then we'll divide by the new power, which is 4. Plus, again here, x power 4, so let's add plus 1 to the power, which will give us 5, and then divide by the new power, which is 5. Plus c, of course, because that's where the dx will go. Now we want to get the value of c. How do we get the value of c? Because now we have two different variables. We have y and we have x. If we had only x, then we could have managed it, but we have two values. But then again, we remember that they've given us the value of y when x equals 1. So when x equals 1, y will equal 2. Hence, we can just substitute it in the equation. So when x equals 1, y will equal 2. So 2 will equal 1 power 4, obviously will be 1 over 4, plus 1 power 5, obviously will still be 1 over 5, plus c. Now we can get the value of c. So let's just transfer here. No? Maybe not. Okay. So we duplicate it. We can just add these two fractions. So cross 5 plus 4 divided by 5 times 4. So 5 plus 4 will get us 9. 5 times 4 will equal 20 plus c equals 2. Transfer 2 to the, or sorry, 9 over 20 to the other side. So 2 minus 9 over 20 will equal c. I can just, do I have the calculator? No, okay, so I'll just do it normally. Again, we'll cross multiply, so 20 times 2 will get us 40, and then minus 9 over 1 times 20 will be 20. So 40 minus 9 will be 31 over 20, and that is the value of c. Okay, now we may take this value as c and then substitute it in here, this equation, as c. So we'll remove c here and we will put 31 over, is it 31? Yes, 31 over 20 as the value of c. And that is our final answer. Y equals x power 4 divided by 4 plus x power 5 divided by 5 plus 31 over 20. And that is the initial value problem when y of 1 equals 2. Use figures and the fact that, okay, so this is a very lengthy question, I've solved it in one of the videos. I've solved, I believe, this one, and then you can solve this one using, or if knowing this, the way to solve this question, you can solve the other question. Evaluate the definite integral. Okay, so definite, there's no plus c here, no plus c. So don't mix between the indefinite and definite integral. Very simple. We will now just get the integral of this. So 3x power 2, so plus 1, it becomes power 3. And then we divide by the new power, which is 3. So we have 3. 3 and 3 will go with each other. Hence it becomes x power 3 plus. Again here, 2x power 1. We'll add 1 to the power. It becomes 2 divided by the new power, which is 2. And then again, 2 and 2 will cancel each other. We get x squared. Finally, we get plus 4. If we have any number, we just put x beside it if we want to get the integral of it. Now we can substitute 3 for each value of x. So it becomes 3 power 3 plus x power 3. Oh, sorry, I mean 3 power 2 plus 4 times 3. 3 power 3 is 27. 3 power 2 will be 9 plus 4 times 3 will be 12. If we add it, here we'll get 21 plus 27. Add 1 here, becomes 20 plus 28, aka 48 is our final answer. Moving on to our our last question in the exam beside the bonus question. Let's actually solve the bonus question. It's very simple. We will, as we said, this is the fundamental theorem of calculus part 2, fundamental theorem of calculus part 2. If we have a derivative and integral, we'll delete and you'll put x beside the t. So 10 plus x. This is our answer. Here, remove x and put t. So sine the under root of t. And here finally, we'll put ln. Instead of t, we write x power 2 plus 1. We don't do anything. We just remove the t and put x beside it, instead of it. So the t, we just make it x. And that's the only thing you do. It's very simple. So moving on to our last question in this video. Figure 5.14 shows the blah, 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 blah. So there are actually many questions in this question alone, but they want us to solve only part A and B. So don't read this question. Just read A. A left sum with n equals 2 subdivision and a right sum with n equals 2 subdivision. So what does it mean? A left sum, as we said, we mentioned before, is underestimate. While a right sum is overestimate. Okay, so if we start with the left sum here, They want two rectangles, so this is our first and this is our second. So anything after that, we don't want to. We don't need it. We just need our first two rectangles here. We'll start with 6, and this will be our first point from 6 to, let's say, 6.1, and then from 6.1 to 8. But since this is a left sum and an underestimate, we will not take it. We will just take it the same value, because if we take it like this, we see that there is an underestimate here. Okay, if we draw it carefully, we see there's still some room over the curve, as you see here, very clearly. Now we can get the area under each rectangle. So delta t, aka the width, equals 2. So this is 2. And then length equals 6. So 2 times 6 is the area of this rectangle. This will equal 12. Again, this is, let's say, 6.1. Width, again, will be 2. So 6.1 times 2 will be plus 2 times 6.1. Now let's actually get the 12. So this will equal 12 plus 2 times 6.1 will be 12.2. If we add them up, we will get 24.2. So this is what this is, left sum. Left sum n equals to subdivision. Okay, just fixing it. Now we can move on to part B, which is right sum, aka overestimate. So this one, we will not start from here because it's the left side. So we'll start from here. This is the right side, and then this is our second right side. So it goes like this, down, and it goes like this, down. Oops, wait, no. Goes like this. So you see very clearly that there's area above the curve, as you see here, like here, you see, for example. Okay, hence this represents an overestimate. So as I said here, the length will be 6.1. Okay, let's change the color to make it more clear. So 6.1 times the length, which is 2, plus our second rectangle we have, our length will be 8 times 2 again. So 6.1 times 2 will be 12.2, plus 8 times 2 will be 16. Now we will add them up, which will get us, so 12 plus 16 will be 28 plus 0.2, because we add the 0.2 here. This, I believe, yeah, we are done with the study guide right now. If we need anything else, you can just text me. If you face any problem in question number, where is it? Question number 11. As I said, there's a video of me explaining it. If you still didn't understand it, then I'll explain it to you in private. And yeah, I believe that's it. Thank you very much. Thank you for watching. See you next time.